Have you ever stopped to think about how your smartphone, this incredibly thin device, actually works? I mean, it's easy to take for granted, but behind that sleek design is some seriously brilliant electrical engineering. It almost feels like it's defying physics. Okay, let's dive into this hidden world.
It really all boils down to one kind of baffling question. You've got all these powerful parts inside your phone. A super bright screen, a lightning-fast processor, that powerful camera flash, but there's only one single slim battery. So how on earth does that one little power source manage to do it all?
All right, to really get why the actual solution is so genius, let's just start with a little thought experiment. Let's imagine we tried to build a smartphone the simple way, with no fancy electrical tricks at all. Okay, so first up, that screen. To get the backlight nice and bright, you need a big old 22-volt battery just for that. Then what about the fingerprint scanner? Well, that would need its own 16.5-volt battery. Oh, and of course, the camera flash would need another separate 5-volt one. You see where this is going? You literally need a different battery for almost every single part.
And what would we end up with? We'd have this ridiculously heavy, clunky brick of a phone. And charging it, a total nightmare. You'd have to plug in each and every battery one by one. This is our impossible phone, a product that, let's be honest, absolutely no one would ever buy.
So that little thought experiment brings us right back to reality and the huge challenge engineers are actually facing. How do they solve this puzzle without creating that monster phone?
Well, it all starts right here. A typical smartphone battery, probably just like the one in your pocket right now, gives you a maximum of about 4.3 volts. That's it. And this single number is where the real problem becomes crystal clear.
This table just lays it all out perfectly. Just look at the screen backlight. It needs 22 volts, but our battery only has 4.3. The fingerprint scanner needs 16.5. Heck, even the camera flash needs more power than the battery can give it directly. This right here is what we call the great voltage gap. It's this massive gulf that engineers somehow have to bridge.
So how do they do it? The answer lies with a tiny, truly unsung hero of modern technology. It's a component that was specifically designed to solve this seemingly impossible problem.
So, allow me to introduce you to the star of our show, the boost converter, also known as a step-up IC. And its superpower? It's as elegant as it is simple. It takes a low voltage input from the battery, and it boosts it into a higher, much more useful voltage.
Probably the easiest way to picture it is like this. It's basically a magical miniature transformer. It takes a little bit of power in one side, and then it precisely outputs a much higher voltage on the other. So the really crucial point here is that it converts what the battery has into what all the other components need.
So how does this little piece of magic actually pull it off? Well, the process behind it is surprisingly simple, but it is incredibly powerful.
Okay, so first, the circuit takes in that low 4.3 volt current from the battery. Easy enough. Then, and here's the really clever part, it uses an internal switch that flips on and off at an unbelievable speed. This rapid switching action stores and accumulates electrical energy. Finally, it releases all that stored up energy as a steady, stable, higher voltage current, sending it exactly where it needs to go, like to the screen's backlight.
And what's so cool is that this brilliant idea isn't just some special trick that's only used in smartphones. It's actually a fundamental principle that you can see at work all across the world of technology.
You can see this principle applying at every single scale. A tiny boost converter in your phone takes low voltage from its small battery to power all the components. Well, a big solar inverter on a house does the exact same thing, just on a much, much bigger scale. It takes the low voltage from solar panels and boosts it to power your entire home. It's the same core idea, just in very different sizes.
And that really brings us to the main takeaway here. Without this tiny, intelligent circuit, the sleek, powerful, all-in-one smartphone that we all use every single day, well, it simply couldn't exist. The bright screen, the powerful flash, all of it is only possible because of this little hero.
And all of this leaves us with a really fascinating question to think about. What other invisible heroes are hidden away inside the technology we use every day, silently working to make our modern world possible?